Maths and Methods Academy. In this video we are going to resolve given algebraic fractions into partial fractions. So let's get on with our solution. The first question of this video is x squared over x minus 1 into x squared plus 1 whole square. Okay, like always, let us check the degrees of the numerator and the denominator that x has. In the numerator it is 2 and in the denominator it is 5, which means it is a proper algebraic fraction. So we can go ahead and form the partial fractions. Its first factor is linear factor. And the second factor is repeated quadratic factor. Why we call it quadratic factor and then repeated? Because the power of x is 2 and it is always 2 in quadratic expressions, and since whole of it is having raised to having power 2, which is this one, it means we have to repeat it 2 times. Like we have to write 2 factors here, 2 partial fractions. So let's go ahead and do this. For x minus 1 we will be having only one constant in the denominator. Then for x squared plus 1 whole square, it is a repeated quadratic factor. So we will be writing 2 partial fractions for it. The first one will have 2 constants with one of them with x, and in the denominator we will write it for the first time without any power and for the second time with the power. So let's multiply both sides by x minus 1 into x squared plus 1 whole square. X minus 1 into x squared plus 1 whole squared, x squared over x minus 1 into x squared plus 1 whole squared is equal to x minus 1 into x squared plus 1 whole square into a over x minus 1 plus bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 whole square, and then bracket close. This cancels with this and we can write x squared is equal to, we will multiply x minus 1 into x squared plus 1 whole square with all the 3 terms inside the bracket, and we will get a into x squared plus 1 whole square plus bx plus c into x minus 1 into x squared plus 1, and then dx plus e into x minus 1. So this is our equation number 1. Here we will assume the value of x as 1. So when we substitute this value of x in the equation, we get 1 squared is equal to a into square of 1 plus 1 whole squared plus b into 1 plus c into 1 minus 1 into 1 squared plus 1 plus d into minus 1 d into 1 plus e into 1 minus 1. So 1 square is 1. So a into 1 plus 1 squared plus, because of this and because of this both the terms will become 0. So 1 is equal to a into square of 2, which means 4a is equal to 1. We divide both sides by 4, which means a is equal to 1 over 4. Now we don't have any value of x that we could substitute in the equation 1 to find out the value of any other constant. So we will simplify the equation now and then compare the coefficients of different degrees of x on both sides in order to form the equations and then figure out the constants from those equations. Let's write it down one more time. X squared is equal to a into x squared plus 1 square plus bx plus c into x minus 1 into x squared plus 1 plus dx plus e into x minus 1. Let us simplify it. Let's open this bracket first, which is a square. So x4 plus 2x squared plus 1 bx plus c. Now we will multiply this one, x cube plus x, then minus x squared minus 1 plus dx squared minus dx plus ex minus e. Okay, now we open the brackets. ax4 plus 2ax squared plus a plus bx4 plus bx squared minus bx cube minus bx plus dx squared minus dx plus ex minus e. Now we will combine the terms with the same degree of x, so that we will be doing ax4 plus bx4 plus bx4, then we have minus bx cubed plus cx cubed. Then we have to write square term, which is 2ax squared plus bx squared plus dx squared here we have forgotten to multiply this c with the rest of the terms, so we will be writing here cx cubed plus cx minus cx squared minus c so it is cx cubed plus cx minus cx squared minus c plus dx squared minus dx plus ex minus e. Now we will combine the terms which are having same degree of x. So first of all it will be ax4 plus bx4. Then we look for the cube value, which is minus bx cubed plus cx cubed. Now we'll look for the square values. The terms of x squared, those are 2ax squared plus bx squared minus cx squared plus dx squared, and in the end we will write those terms which are without any variable x. So it is a, then minus c, x values, we don't have any a in x value. X value it is minus bx, then we have plus cx, then we have minus dx, and then we have plus ex. And in the end we are left with those terms which are not having any x attached to them. So a minus c and minus e. Okay, in the first two terms x4 is common. In the next two terms minus b plus c will be inside bracket and outside x cubed, and then in the next four terms 2a plus b minus c plus d, and outside it will be x squared. Then plus minus b plus c minus d plus e, outside it will be x, and then we have those terms which are without the x. Okay, let's write down the left side also. 0x4 plus 0x3 plus 1x squared plus 0. Now we will compare the coefficients of x4, which are this one. So a plus b is equal to 0. We have already calculated the value of a, which is 1 over 4, which means b will come out to be minus 1 over 4. After that we will compare the coefficients of x cube. So that will be minus b plus c is equal to 0. We have calculated the value of b, which is minus 1 over 4, plus c is equal to 0. So 1 over 4 plus c is equal to 0, which means c is equal to minus 1 over 4. Now we have already calculated three values, a, b and c. Now we will compare both sides. For the terms which are without x, which are this one, so a minus c minus e is equal to 0. A is 1 over 4, c is minus 1 over 4, so it will be 1 over 4 plus 1 over 4 minus e is equal to 0. We will take LCM of both the fractions. So it is 2 over 4 plus e is equal to 0. This cancels. So the value of e is equal to 1 over 4 minus into minus e is equal to 0. Then this e is minus here, my mistake. So e will come out to be 1 over 2. In the end, we will compare the coefficients of x, and coefficient of x we forgot to write here, it is 0x. So when we compare it, we will have minus b plus c minus d plus e is equal to 0. b is minus 1 over 4. c is also minus 1 over 4. And d we don't have until now. E is equal to 1 over 2 is equal to 0. Let's simplify this. Minus into minus 1 over 4 is plus 1 over 4. Then minus into plus into minus minus. Minus d plus 1 over 2 is equal to 0. This cancels with this, which means our d is equal to 1 over 2. Now we have found all the values a, b, c and d and e. So we can write the partial fractions. X squared over x minus 1 into x squared plus 1 squared is equal to 1 over 4 over x minus 1 plus minus 1 over 4x minus 1 over 4 over x squared plus 1 plus 1 over 2x plus 1 over 2 over x squared plus 1 whole square. Let's simplify it further. 1 over 4x minus 1. We'll take minus common here. So we will have x minus 1 over 4 when we take the LCM of both the fractions. Sorry, it will be plus because we have taken minus common, over x squared plus 1. Here again we will take LCM. It is 1 over 4 into x minus 1 minus x plus 1 over 4 into x squared plus 1 plus x plus 1 over 2 into x squared plus 1 whole squared, which is the answer of this question. Now we move on to our second question, which is x4 over x squared plus 2 whole squared. Here in this question, the degree of x in the numerator is 4 and the degree of x in the denominator is also 4, which means it is not a proper algebraic fraction, so we have to divide the numerator with the denominator. But before we do that, we have to open the bracket in the denominator. So we will have x4 plus 2x squared plus 4. Let's divide it. We'll divide x4 by the denominator. We will be writing x4. Since we don't have any x squared value, so we'll write 0, and we don't have any constant, so we'll write 0. And now we will write here x4 plus 2x squared plus 4. We have to multiply x4 with some term which will give us x4. This x4 we have to multiply with some terms which will give us this x4. So obviously it is 1. So when we multiply it by 1, we get x4. We will multiply 1 with this 2x squared also, and we multiply this one with this 4 also. Now we subtract it, so sign will change. This terms cancels, so we are left with 2x squared minus 4. Again my mistake, it is 4x squared. So we are getting minus 4x squared minus 4 as numerator now. So we will be writing it like 1 plus minus 4x squared minus 4 over x squared plus 2 whole squared. 1 minus 4x squared plus 4 over x squared plus 2 squared. Now for the time being, we will ignore this one and we will solve this algebraic fraction, and we will make partial fractions of this. So let's write down this separately. 4x squared plus 4 over x squared plus 2 squared whole squared. So we'll be writing it like ax plus b over x squared plus 2, because the factor that we have, it is a repeated quadratic factor, so it will have another factor also, another partial fraction, cx plus d over x squared plus 2 whole squared. Now let's multiply both sides by x squared plus 2 whole square. 4x squared plus 4 over x squared plus 2 whole squared ax plus b over x squared plus 2 cx plus d over x squared plus 2 whole square. This cancels with this and we are left with 4x squared plus 4 is equal to, we will multiply x squared plus 2 whole square with both the terms inside the bracket. So in that case we will be getting ax plus b into x squared plus 2 and then cx plus d. Here in this case we cannot assume any value of x to find the values of the constants, so we will straight away go ahead and solve the equation. So we will open all the brackets. This is ax cube plus 2ax plus bx squared plus 2b plus cx plus d Now we will combine the terms with the same degree of x. Ax cubed plus bx squared plus 2ax plus cx plus 2b plus d. So we will take x common and we will be left with 2a plus c in the bracket, and we have one expression 2b plus d which is without any x. On the left side we will be writing 0x cubed plus 4x squared plus 0x plus 4. First of all we will compare the coefficients of x cube. So a is equal to 0. Then we will compare the coefficients of x squared. So in that case we will get b is equal to 4. Then we will compare the coefficients of x. So we will get 2a plus c is equal to 0. We have the value of a as 0 plus c is equal to 0, so it means c is also equal to 0. And then we compare the coefficients of the terms which are without x. So 2b plus d is equal to 0. Sorry, it is 4. b is 4 plus d is equal to 4, which means 8 plus d is equal to 4, and d is equal to 4 minus 8, which means d is equal to minus 4. Now we have calculated all the 4 constants, so we can form our partial fractions. So we will be writing x4 over x squared plus 2 whole square. When you are writing the partial fractions, please don't forget to write the one which you have left in the beginning. 0x plus 4 over x squared plus 2 plus 0 into x minus 4 over x squared plus 2 whole square. So we are getting 1 minus 4 over x squared plus 2. And here we have minus 4. This minus 4, when it will multiply with minus, it will become plus 4 over x squared plus 2 whole squared. And this is the answer of our question. Now we move on to our last question of this video. It is x5 over x squared plus 1 whole squared. Here the degree of numerator is 5 and degree of denominator is 4, which means it is improper algebraic fraction. So we have to divide the numerator by the denominator. For that purpose, we first have to open the bracket in the denominator. We will be getting x4 plus 2x squared plus 1. So let's divide it. x5 will be inside 0x4 0x cube actually, because we don't have that, or we can write 0x4 also plus 0x cube then 0x squared 0x plus 0. Now here we will be writing x4 plus 2x squared plus 1. So with which term we have to multiply x4 to get x5? Obviously it is x. So let's multiply it with this one. So we'll get x5. Then we multiply it with this one. We will get 2x square. And then we multiply it with this one. We will get x. 2x cube actually. No, 2x square. 2x cube and then x. The signs will change. This will cancel with this one. And we are left with minus 2x cubed minus x. So now we can write it like x plus minus 2x cube minus x over x squared plus 1 whole squared, and that can also be written as x minus 2x cube plus x over x squared plus 1 whole squared. This one we will ignore for the time being, and we will take only this term and make partial fractions of this. So this term is 2x cubed plus x over x squared plus 1 whole square. So here the factor that we have in the denominator, it is repeated quadratic factor. So this one will be, whenever we have this situation, we'll be writing two partial fractions. In the first one, in the numerator, we have one constant with x and one without it, and in the second one we will be again having one constant with x and one without it, and in the denominator we will be having this expression with the square. Let's multiply both sides by x squared plus 1 square. Okay, this cancels with this and we are left with 2x cubed plus x is equal to, now we will multiply x square plus 1 whole square with both the terms inside the bracket. So we will be getting ax plus b into x squared plus 1 plus cx plus d. Here we cannot assume any value of x and then replace it in the equation to find out the value of any of the constants. So we straight away go ahead and solve this equation and compare the coefficients of different degrees of x on both sides, and then form the equation and solve those equations to get the values of a, b, c and d. Ax cubed plus ax plus bx squared plus b plus cx plus d. Here we can write 2x cubed plus 0x squared plus x plus 0. So here we will write the terms with the same degree of x. So ax cubed plus bx squared plus ax plus cx plus b plus d. Ax cubed, bx squared, and x common here in these two terms, and the last one is without the x. First we will compare the coefficients of x cube. It gives us a is equal to 2. Then we compare the coefficients of x squared. It gives us b is equal to 0. Then we compare the coefficients of x. So it gives us a plus c is equal to 1. We have the value of a as 2, which means c is equal to 1 minus 2. C is equal to minus 1. Then we compare the coefficients of the terms which are without x. This will give us b plus d is equal to 0. We have the value of b as 0, which means d is also 0. Okay, now we have found all the values of a, b, c and d, so we can write our partial fractions. x5 over x squared plus 1 whole square is equal to, don't forget to write the term x which we have left in the beginning, 2x plus 0 over x squared plus 1 minus x plus 0 over x squared plus 1 whole squared. So x minus 2x over x squared plus 1 and then this minus and this minus will become positive, x over x squared plus 1 whole squared, and this is the answer of our question. That's all for now. Please don't forget to subscribe the channel, and until the next time, take care and bye.